Right now, thick black smoke is turning bright daylight into pitch black night across an entire American region. It looks like a single small forest fire burning out of control somewhere in the distant woods. Not one fire. 4 separate infernos are devouring everything in their path at the exact same moment, forcing tens of thousands of people to run for their lives as a giant wall of flame swallows entire neighborhoods. If you love exploring real science and dramatic real-world mysteries backed by solid facts without any hyperbole, make sure to hit the subscribe button right now. Joining our community ensures you will always be the first to understand what is truly happening on our fast-changing planet. To understand how this massive disaster unfolded so quickly, we have to look closely at where it is happening. Spokane is the second largest city in the state of Washington, home to over 200,000 people. Nestled in the heart of eastern Washington, this vibrant urban hub is surrounded by majestic ponderosa pine forests, rolling golden wheat fields, and calm lakes. For generations, people moved to this area because it offered a perfect mix of city, convenience, and wild mountain nature right in their backyard. But that beautiful combination of pine trees and residential developments carries a massive hidden danger that fire scientists have warned about for decades. During the peak of late summer, eastern Washington transforms into a dry timber oven. The region sits directly in the rain shadow of the giant Cascade Mountains, which means it receives far less rain than coastal cities like Seattle. By late August, weeks of scorching sun suck every single drop of moisture out of the tall grass, dry brush, and dense pine trees. The brown pine needles coating the forest floor become as dry and flammable as dry paper in a furnace. All that is needed to trigger a complete disaster is a single spark and a strong summer wind. The geological setup of this region makes it uniquely vulnerable to seasonal fire events. Millions of years ago, massive volcanic eruptions covered eastern Washington in thick basalt rock, creating a wide plateau with rich but shallow soil. In this environment, grasses grow thick during the damp spring months and then die off completely when summer arrives. This creates a massive, continuous layer of dry fuel across hundreds of square miles. When winter snows melt early, as they have in recent decades, the drying process begins weeks ahead of schedule, setting the stage for disaster long before late summer hits. On a blisteringly hot afternoon, that exact nightmare scenario became a sudden and terrifying reality. The emergency started near small, peaceful communities just outside Spokane, including Medical Lake and Elk. Local air temperatures climbed well over 100 degrees Fahrenheit, while humidity levels in the air dropped to razor-thin single digits. Then, violent wind gusts began sweeping across the dry landscape at speeds over 40 miles per hour. A minor equipment issue or spark on the ground hit the parched brush, and within seconds, a tiny flicker of light transformed into a roaring monster. When a wildfire ignites under these extreme atmospheric conditions, it does not creep slowly along the soil like a campfire. It explodes outward in every direction with shocking and relentless speed. First responders on the scene reported that the flames were moving faster than an adult human could run, expanding across thousands of acres in less than 2 hours. The thermal energy was so intense that evergreen trees were not just catching fire, they were literally exploding from the inside as trapped sap turned instantly to superheated gas. When wildland firefighters first arrived on scene, they expected to follow standard textbook procedures. They planned to build clear dirt lines around the edges of the fire, using heavy bulldozers to starve it of fuel and keep it contained within the forest. But what actually happened stunned even the most veteran fire captains on the West Coast. The inferno generated so much intense heat that it created its own localized weather system, complete with giant smoke clouds rising miles into the air. Here is the exact detail that left experts in absolute shock. The fire began throwing massive clouds of burning pine cones and wood embers up to 2 miles ahead of the main fire front. This massive gap between what firefighters expected and what actually happened created an impossible situation on the ground. Digging dirt trenches on the forest floor does nothing when the fire is flying high over your head through the sky. Every time a glowing ember landed in the dry brush ahead, a brand new fire ignited in a matter of seconds. Fire crews that thought they were standing safely behind the front lines suddenly found themselves completely surrounded by fresh walls of flame. The physics of this phenomenon, known to scientists as spotfiring, transformed a single fire line into a chaotic web of dozens of independent blazes. As superheated air rises rapidly above a major forest fire, it creates a powerful vacuum at ground level. Cold air rushes in from the sides to fill that vacuum, generating fierce, localized winds that blow embers high into the atmosphere. These glowing embers can travel long distances on high-altitude air currents before dropping into unburned neighborhoods, ignition points that human firefighting crews simply cannot predict or keep up with. Did you know that extreme wildfires can actually create their own lightning storms that start even more fires miles away? If facts like this amaze you as much as they amaze us, please hit the like button and leave a quick comment below with your thoughts. Your support helps us bring these incredible scientific stories to thousands of curious minds around the world. As multiple blazes merged together and charged directly toward populated suburban neighborhoods, local emergency authorities had to make a choice that every city official dreads. Loud emergency sirens began to blare across the county, and mobile phones in thousands of living rooms vibrated with urgent tone alerts. Officials issued Level 3 evacuation orders, which in official emergency terms means one simple thing: go now. Over 62,000 residents were told to drop whatever they were doing and flee for their lives immediately. Imagine receiving an emergency alert on your phone telling you that you have less than 5 minutes to pack your entire life and run. Over 62,000 people is roughly equal to filling a massive professional sports stadium to total capacity. Now, picture every single person in that crowded stadium trying to drive down the exact same two-lane country roads at the exact same minute. Major roadways like Interstate 90 quickly transformed into bumper-to-bumper parking lots as dense gray smoke cut driver visibility down to almost zero. The psychological impact of a sudden evacuation order on a community is profound. When people are told they have only moments to leave, decision-making becomes extremely difficult under intense stress. Families must make split-second choices about whether to grab important legal papers, photo albums, medicine, or family pets. In many cases during the Spokane evacuations, people had to leave behind vehicles, family memories, and livestock because the thick black smoke was already wrapping around their homes and making breathing almost impossible. For decades, urban planners and local residents believed that physical barriers would always protect the city from wild forest fires. Everyone expected that major multi-lane concrete freeways, wide paved roads, and the flowing waters of the Spokane River would act as natural fire breaks. Pay close attention to what happened next, because this is where the story takes a truly terrifying turn. The roaring gale force winds pushed the inferno straight over 6 lanes of highway traffic and across wide bodies of water without slowing down even for a second. This outcome completely shattered a common myth that many people living near dry forests rely on for a false sense of security. A wide river or a paved road can easily stop a light ground fire, but it cannot stop superheated air and glowing ember storms carried by 40-mile-per-hour winds. When the fire jumped over Interstate 90, it proved that modern human infrastructure cannot block a weather-driven firestorm. The flames transitioned instantly from burning pine trees to consuming suburban subdivisions, turning residential houses into fresh fuel blocks. The science behind how fire jumps large gaps lies in radiant heat and convection currents. When a forest fire reaches maximum intensity, the air temperature at the flame front can exceed 2,000 degrees Fahrenheit. At this temperature, materials across a wide highway do not even need to touch direct flames to catch fire. They reach their auto-ignition point purely from the intense thermal radiation beaming through the air. Combined with millions of wind-blown embers raining down from above, a 6-lane highway offers virtually zero defense against a full-scale wildfire storm. When a wildfire reaches a residential neighborhood, the fundamental nature of the fire completely changes. Instead of feeding on moist forest vegetation, the flames begin feeding on dry wooden roofs, plastic siding, wooden decks, and propane tanks inside private garages. Suburban houses burn much hotter and longer than forest trees because of the dense synthetic building materials packed inside them. A single burning house generates enough radiant heat to ignite the structures on either side of it, creating a dangerous domino effect that can destroy an entire residential block in under an hour. The structural materials used in modern suburban home construction create a unique thermal signature when burned. Asphalt roof shingles, vinyl siding, fiberglass insulation, and pressure-treated wooden decks are packed with petroleum-based compounds. When these materials ignite, they release massive amounts of energy and dense black chemical smoke. This chemical fire burns significantly hotter than organic wood fires, creating thermal plumes that elevate ground temperatures and cause nearby vegetation and structures to ignite almost instantaneously. Have you ever thought about what 3 important items you would grab if you only had 2 minutes to evacuate your house? Take a quick moment to write your emergency choices in the comments below, and do not forget to subscribe to the channel if you want to stay informed on how our world is changing. Hearing your real perspectives helps make our scientific community much stronger. Emergency response agencies spend years training for natural disasters using carefully calculated timetable models. They expected that an evacuation order of this size would take several hours to execute, allowing police officers to clear streets in an orderly, organized fashion. What actually occurred was a desperate, chaotic race against a wall of fire that was advancing faster than localized traffic could move. What scientists discovered in the hours following the blast of heat changed everything. The fire was moving through suburban streets at speeds exceeding 15 miles per hour. A line of cars, stuck in heavy traffic on a narrow exit ramp, moves at barely 3 miles per hour, while the advancing fire behind them moves at 15 miles per hour. That 5-to-1 speed advantage meant many families were forced to abandon their vehicles on the side of the road and flee on foot through choking smoke. Local heroes, including off-duty police officers, firefighters, and everyday neighbors, ran door to door pounding on windows to drag elderly residents out of their living rooms, just seconds before the roofs collapsed. During these frantic moments of escape, visibility on the roads dropped to near zero as thick plumes of dark smoke settled over the asphalt. Drivers had to navigate by following the taillights of the car in front of them, or by feeling the vibration of rumble strips on the road shoulders. The heat outside vehicle windows grew so intense that plastic trim on car doors began to warp and melt as families drove through corridors of burning trees. It was a harrowing reminder of how quickly a familiar suburban commute can turn into a life-threatening situation. The total destructive footprint of this wildfire outbreak was staggering. Over 700 structures, including hundreds of primary family homes, small businesses, and agricultural barns, were completely leveled to the ground. In hit neighborhoods like Medical Lake, entire streets were reduced to flat piles of gray ash and melted metal with only brick chimneys left standing like sad monuments. The total property damage quickly climbed into tens of millions of dollars, leaving hundreds of local families with nothing left but the clothes on their backs. When fire investigators toured the destroyed neighborhoods after the flames receded, they documented a striking pattern of selective destruction. In some areas, 5 houses in a row were completely vaporized, while a house right next door suffered only minor heat damage to its exterior paint. This bizarre pattern happens because subtle differences in wind currents, roof material, gutter cleanliness, and landscaping can determine whether a home catches fire from an airborne ember or survives untouched. While the flames were physically destroying homes on the ground, the fire was launching a silent airborne attack that affected millions of people far beyond the evacuation zones. As forest trees, suburban houses, vehicles, and synthetic materials burned together, they pumped millions of tons of dangerous microscopic soot into the upper atmosphere. The giant smoke column rose miles into the sky before spreading out like a dark blanket across eastern Washington, northern Idaho, and western Canada. To measure how dirty or clean the surrounding air is, atmospheric scientists use a standard environmental metric called the Air Quality Index, or AQI. Under normal conditions, a healthy and clean air quality reading ranges from 0 to 50. Anything over 300 is considered officially hazardous, meaning even healthy adults should stay indoors with air purifiers running. During the peak of the Spokane wildfire outbreak, monitoring stations recorded unbelievable AQI levels reaching 511. This next piece of information is the part most people never forget. Spokane officially recorded the worst air quality of any major city on the entire planet for 2 full days. The health risks associated with breathing air at an AQI level above 500 are severe and immediate. Microscopic particles known as PM 2.5, which are tiny bits of soot smaller than a single human hair, travel deep into human lungs and enter the bloodstream directly. Exposure to high levels of PM 2.5 can trigger acute respiratory distress, heart attacks, and severe asthma attacks, even in young, healthy individuals. For vulnerable populations like children and senior citizens, staying outdoors during an event of this magnitude can cause permanent lung damage. Would you be able to stay trapped inside your house for days if the air outside became toxic to breathe? Let us know in the comment section how your hometown handles summer smoke, and make sure to subscribe so you never miss another deep dive into earth science mysteries. Engaging with these questions keeps all of us prepared for the unexpected. For decades, conventional fire science treated wild forest fires and suburban structure fires as 2 completely separate categories. Scientists expected that natural forest vegetation like dry grass and pine trees would act as the primary power source driving the fire. But when researchers analyzed thermal readings from the Spokane region, they uncovered a disturbing truth that is forcing experts to rewrite safety manuals. The dense concentration of man-made materials in suburban developments created a localized microclimate of incredible heat that made the fire burn far hotter than it ever did in the open forest. This realization is terrifying for modern city planners because millions of people across North America live in what scientists call the Wildland-Urban Interface, or WUI. When homes are built close together inside or near dry pine forests, the buildings themselves become the primary fuel source. Instead of the forest burning down the town ends up feeding the forest fire. The extreme thermal output from burning roofs and gasoline tanks creates powerful updrafts that suck in surrounding oxygen, triggering even stronger winds and speeding up the destruction. Understanding the physics of the Wildland-Urban Interface is changing how scientists evaluate disaster risk across the globe. As suburban communities continue to expand deeper into natural wilderness areas, the line between forest and neighborhood blurs completely. When a wildfire crosses into this transition zone, traditional firefighting equipment designed for forest timber becomes far less effective against intense structural fires. Fire departments are forced to pivot from containment strategies to life safety rescues, leaving structures to burn because water supplies are quickly overwhelmed. Right now, as you listen to these words, Emergency crews are still actively battling smoldering hotspots across thousands of acres of charred land. While firefighters have managed to gain valuable containment thanks to cooler weather shifts and heroic groundwork, the overall situation remains active and delicate. National Guard troops, heavy water scooping aircraft, and specialized incident management teams are working around the clock to make sure hidden embers buried beneath the ash do not reignite in the sun. The aerial arm of modern wildfire fighting plays a crucial role during active fire containment operations. Massive fixed-wing tanker aircraft drop thousands of gallons of bright red fire retardant along ridgelines to slow the fire advance. At the same time, heavy helicopters dip giant buckets directly into local lakes to drop targeted water loads on dangerous hotspots. However, when winds exceed 35 miles per hour, or smoke reduces visibility below safe flight thresholds, these multi-million-dollar aircraft are grounded, leaving firefighters on the soil to fight the flames by hand. In the face of such overwhelming destruction, the human response on the ground has been nothing short of extraordinary. Emergency first responders risked their lives diving into blinding smoke zones to rescue trapped residents and lost pets. Local community colleges, fairgrounds, and high schools transformed overnight into massive emergency shelters, offering warm food, medical care, and clean beds for thousands of displaced families. Neighbors who had never spoken before were suddenly sharing supplies, housing livestock, and helping clear dry brush around remaining structures. The operational scale of setting up emergency shelters for tens of thousands of displaced people requires incredible logistical effort. Relief agencies like the Red Cross, local food banks, and Army units worked in tandem to establish clean water distribution sites, mobile kitchen facilities, and pet evacuation shelters. Medical personnel set up makeshift clinics inside gymnasium spaces to treat residents suffering from smoke inhalation, minor burns, and high anxiety. These efforts provided a vital safety net for families who had lost everything in a matter of hours. In our modern high-tech world, we rely heavily on advanced weather satellites, thermal camera towers, and predictive computer models to keep us safe. Officials expected these sophisticated early warning systems to give emergency managers hours of advance notice before a fire reached critical threshold levels. Here is the unexpected truth that scientists are coming to terms with right now. Sudden wind shifts and extreme dryness can accelerate a wildfire far faster than satellite images can update, leaving human decision-makers scrambling to react. Satellites orbiting high above the Earth refresh their thermal data periodically, but a wind-driven wildfire can travel several miles in less than 15 minutes. This means computer models predicting fire direction can become obsolete almost as soon as they are printed out on paper. Scientists now realize that while satellite technology is an incredible tool, rapid human communication, local ground observations, and immediate emergency warnings remain our most vital lines of defense when nature releases its full energy. The technical gap between satellite detection and ground reality comes down to data latency and cloud interference. Geostationary weather satellites orbit over 20,000 miles above the Earth, while low Earth orbit satellites pass over a specific region only a few times per day. Furthermore, the massive pyrocumulus smoke clouds generated by major infernos can obscure thermal sensors on satellites, blocking their view of active flame fronts below. By the time a satellite processes a clear thermal anomaly image, the fire on the ground may have already traveled past 3 suburban blocks. Do you think cities should stop building new housing developments near dry forest zones to prevent disasters like this? Share your opinion in the comments below, and hit the subscribe button to keep exploring the delicate balance between human civilization and nature. We love reading your thoughtful comments on these complex environmental issues. When we look at the numbers behind this event, the total scale of the disaster becomes truly mind-boggling. The wildfire burned through more than 28 square miles of land across Spokane County. To put that number into clear everyday terms, 28 square miles is equivalent to over 14,000 standard athletic fields placed end to end. Over 700 total buildings were destroyed, causing tens of millions of dollars in direct property losses, and creating disruptions that will take years to fully fix. Beyond the immediate human impact, the long-term ecological damage to the Washington landscape is deep. Thousands of old-growth ponderosa pine trees that stood proudly for over a century were reduced to blackened stumps in a matter of hours. Local forest habitats were destroyed, forcing wild animals like deer, coyotes, and native birds to flee into unfamiliar urban areas. The intense destruction of organic topsoil also creates a serious future risk of dangerous mudslides when heavy autumn rains eventually return, because there are no plant roots left to anchor the soil. When a severe wildfire bakes forest soil at temperatures exceeding 1,000 degrees Fahrenheit, it triggers a chemical change known as soil hydrophobicity. The intense heat vaporizes organic compounds in the topsoil, which then condense into a waxy, water-repelling layer just beneath the surface. When heavy autumn rains finally fall on burnt ground, the soil cannot absorb a single drop of water. Instead, rainfall washes over the surface like water flowing across glass, collecting loose ash and gravel to form fast-moving mudslides that can sweep away roads and pollute local watersheds. What happened in Washington state is not an isolated incident occurring in a vacuum. Over recent decades, average summer temperatures have steadily increased, leading to longer, drier, and much hotter seasons across the western United States and Canada. Winter snowpack on the mountains melts much earlier in the spring, leaving forests dry and vulnerable for longer stretches of time before cold weather returns. As a result, wildfire seasons that used to last just a few weeks in late summer now extend across multiple months of the year. The scientific consensus regarding changing seasonal patterns highlights a dramatic shift in fire frequency and intensity across North America. Warmer atmospheric temperatures increase the rate of evapotranspiration, a process where heat draws moisture out of soil and plant leaves at accelerated speeds. This drying effect turns vast wilderness regions into fuel-rich tinderboxes long before the peak of summer. As a result, forest ecosystems that historically experienced low-intensity fires every 20 years are now suffering catastrophic canopy, destroying blazes on a regular basis. This shifting reality forces all of us to ask tough questions about how human communities will adapt moving forward. As population numbers grow, cities naturally expand outward into forested areas, placing more homes directly in harm's way. Architectural experts and civil engineers are now advocating for strict new construction rules that require fire-resistant metal roofs, ember-proof window screens, and wide defensible space zones around every single home built near wild timber. Creating defensible space around a home involves removing flammable vegetation within a 30-foot perimeter of the structure, replacing wooden fences with metal fencing, trimming low-hanging pine tree branches, and cleaning dry pine needles out of roof gutters dramatically reduces the chance that an airborne ember will ignite a house. Communities that implement these firewise standards report significantly higher home survival rates during major wildfire events, proving that simple preventative maintenance can save entire neighborhoods. When people watch a wildfire story on the evening news, they often expect life to return to normal within a few weeks after the flames are extinguished. But the reality for disaster survivors is a long, difficult journey that takes years of hard work. Rebuilding hundreds of homes at the exact same time places a massive strain on local building supplies, trade workers, and insurance providers. For many families, recovering from the emotional loss of family heirlooms and personal memories takes far longer than rebuilding physical walls. The economic aftermath of a major disaster ripples through a regional economy for years following the event. Local tax revenues plummet as destroyed properties lose taxable value, squeezing municipal budgets just when funding is needed most for infrastructure repair. Insurance companies often adjust risk algorithms across the entire region, leading to skyrocketing insurance premiums or policy cancellations for thousands of homeowners who were not even directly impacted by the fire itself. If you were forced to rebuild your life after a sudden natural disaster, what community support do you think would matter most to your family? Drop a comment below with your thoughts and click the like button to help share this video with others who care about environmental science. Your active engagement helps our channel produce high-quality educational content every single week. When we step back and view the Spokane wildfire event in its broader context, it connects directly to things every single person cares about: our safety, our homes, and our collective future. Earth is a dynamic, powerful planet that can change instantly, reminding us how delicate our modern daily lives truly are. Whether you live near a forest in Washington, on a coastal beach, or in a bustling city center, understanding how natural forces operate is a crucial part of living safely on our planet. The story of the Spokane Inferno serves as a clear warning sign for communities around the globe facing shifting climate realities. It demonstrates that natural hazards do not respect municipal boundaries, multi-lane highways, or human timelines. Building resilient communities in the modern era requires a fundamental shift in how we design our cities, manage our wilderness areas, and prepare individual households for unexpected emergency scenarios. Yet, even amid the ashes and heavy smoke of eastern Washington, there is also an inspiring story of human strength and unity. Communities do not fall apart when natural disasters strike. They come together tighter than ever before. Neighbors helping neighbors clear debris, volunteers donating food and supplies, and scientists working tirelessly to design better warning systems reveal the very best of human nature. We cannot prevent every natural hazard, but through science, preparation, and working together, we can protect our loved ones and build stronger communities for tomorrow. The ultimate measure of a community is not whether it encounters hardship, but how it responds when tested by unimaginable adversity. As the residents of Spokane County clean up the debris, plant fresh saplings, and lay new foundations for homes, they demonstrate an unbreakable spirit that defines human history. Their resilience gives us hope that no matter how powerful natural forces may be, human compassion and determination will always shine through the darkest smoke. If this deep dive into the Spokane wildfire crisis gave you valuable insights into our planet, please take a moment right now to hit the subscribe button and turn on the notification bell so you never miss our upcoming science stories. Drop a comment below answering this specific question. What is the single most important lesson cities should learn from this wildfire outbreak? Do not forget to share this video with a friend or a family member who loves learning about real-world events and earth science. Thank you so much for watching, and we look forward to exploring the fascinating mysteries of our changing world with you in the very next video.